All right, let's dive into a massive and, frankly, a really underestimated risk in the AI world today. And that's the security of plugins and extensions. These tools are what give our AI systems superpowers. They connect them to live data, to our internal apps, to the internet itself. But in this big race to innovate, we're also creating some brand new and very serious entry points for attackers. So let's break down that risk and figure out how to manage it.
So, picture this. Your team just rolled out a new AI plugin. Everyone's excited, productivity is soaring. Maybe it's hooked up to your database, your cloud storage, or even the company wiki. But if you're a security leader, your first thought should probably be, what did we just connect to what? And more importantly, how could an attacker abuse that connection? To really get a handle on this risk, we need a simple but powerful way to think about it. Imagine your AI as an employee. Every single plugin you enable is like handing that employee a new set of keys.
This right here frames the issue perfectly. That web browsing plugin, that's not just a tool, it's a master key to the entire internet. And that database plugin, well, that's the key to your company's crown jewels. And remember, you're not just giving the AI access, you're giving it the power to use that access on its own.
And this is the absolute core of the problem. An attacker doesn't need to breach your firewall if they can just trick your AI into using the keys you already gave it. It's done with a technique called prompt injection, where an attacker basically hides malicious commands inside a totally normal-looking query. And just like that, your trusted AI can be turned into an insider threat, doing exactly what the attacker wants.
So, how exactly does this all go wrong? Well, the risks really break down into three distinct categories. And understanding these is the first step to building a real defense.
It's really this simple. The plugin itself can be the attacker from day one, or it can become the victim of a hack. Or, and this is the sneaky one, it can be turned into a weapon just by tricking your AI. Each of these scenarios needs a totally different defensive mindset.
Okay, this table breaks down those three failure modes. Let's walk through them. First up, the malicious plugin. This thing is designed to do harm from the get-go, like a tool that seems helpful but is secretly siphoning off your data. Second, the compromise plugin. This one is a legitimate tool, but its own servers get hacked, turning it into a backdoor right into your system. And finally, and this is the most subtle threat of all, the exploited plugin. Here, the tool itself is totally secure, but an attacker uses prompt injection to fool your AI into using it to, say, delete a bunch of critical files.
And look, this isn't just some theoretical concern we're dreaming up. The security community is taking this very, very seriously. OWASP, the nonprofit that pretty much sets the standard for web app security, has officially named insecure plugin design one of the top 10 most critical vulnerabilities for large language models. It is officially on the map as a major risk.
So the key takeaway is right here in this quote. This isn't about just one or two bad plugins. It's about a systemic, industry-wide weakness. These tools are being built for functionality first, and security is often a distant second. As a security leader, your default assumption has to be that plugins are insecure until you can prove otherwise. Okay, so we've defined the problem. It's big, it's complex. What in the world do we do about it? Well, the answer isn't to just ban all plugins. The answer is to build a strategic, multi-layered defense.
This is the framework every security manager should be using. And it's not a single magic bullet. It's 4 layers that all work together. You've got vetting what comes in, applying least privilege to what it can do, sandboxing it to contain any damage, and then monitoring everything it does.
Layer 1 is your front door security. You wouldn't let just anyone wander into your office building, so why let any old plugin into your environment? This means doing security reviews before you enable anything. Who made it? What permissions is it asking for? Does a simple weather plugin really need access to your entire file system? Your goal here is to maintain an approved whitelist of plugins, not a blacklist of the bad ones you've already found.
All right, now let's talk about the keys themselves. Once a plugin is approved, you give it the smallest, most specific key possible. This is the classic principle of least privilege. Grant only the absolute minimum permissions it needs to do its job. That way, you limit what an attacker can accomplish if it gets compromised. Use credentials that expire, so a stolen key has a really short shelf life. And for those high-risk actions, like deleting data, make sure you require an extra checkpoint, what we call just-in-time elevation.
This layer is all about damage control. You have to assume that eventually a plugin will be compromised or exploited. It's just a matter of time. So when that happens, you have to contain the blast radius. Run these things in isolated containers so they can't snoop around the rest of your network.
Put in fail-safes like rate limits to stop an automated attack dead in its tracks. The whole goal is to make sure one compromised plugin can't burn down the whole building.
And finally, you need visibility, because you can't stop what you can't see. This means logging every single thing a plugin does, what it was asked to do, the parameters it used, and what happened next. You need to be monitoring for weird patterns, like a plugin being used at 3 a.m. or suddenly trying to access sensitive files. And you need to alert a human when high-risk stuff happens. This is your alarm system.
Now, let's just bust a couple of dangerous myths real quick. First, this idea that official plugin stores are automatically safe. They're not. Store reviews are imperfect, and malicious plugins absolutely slip through. A listing in a store is not a security certification. Second, the myth that your AI can't be tricked. Prompt injection isn't about fooling an AI's consciousness. It's just about feeding it malicious instructions that its programming basically forces it to follow.
So, with all this, 4 layers, 3 different threat vectors, where do you even begin? I know it can feel a little overwhelming, but the strategic priority is actually very, very clear.
So what is your first move? It's simple. Reduce your attack surface. Before you even think about investing in complex defenses, just review what you have enabled right now. Every single unnecessary plugin you can disable, every single excessive permission you revoke, that's an immediate security win. Your strongest defense right out of the gate is a minimalist approach.
So I'll leave you with this question. As you think about your own organization, which key have you handed out that keeps you up at night? Which plugin, probably enabled for convenience, has way too much access? Answering that question, that's your real starting point. Thanks for tuning in.